Bieberstein. I'm a horse specialist at the University of Georgia, and we are inside today. We're continuing our Forage education video series, and we are going to talk about how to read a forage report. So in our last video, we showed you how to take a forage sample. Once you take that forage sample, it gets sent off to a lab, and that lab analyzes it and sends you back a forage report. So what I have here on my computer is an example of a forage report, and what we're going to do today is we're going to walk through it in each section step by step, and we're going to break down what each part means and how we can get an idea of that forage quality by looking at this forage report. So let's go ahead and jump in, and we're going to start by kind of breaking down this forage report from the beginning.
In our last video, we discussed how to take a forage sample or how to work with your county agent to send in a forage sample for analysis. Today I'm going to walk you through what happens once you submit your sample and get a forage analysis back. First, if you worked with your county agent to submit the sample, they will typically send it to a lab in Athens called the University of Georgia Feed and Environmental Water Lab. You're going to work with your county agent to determine which of the many tests that are available best fit your sample to get you the information that you need. There are two basic ways that the lab can analyze your sample. The first is through wet chemistry, and this is where the lab uses traditional laboratory tests to directly measure the different components in your feed or forage sample. The second way that the lab can use is called an NIR analysis, which stands for Near Infrared Reflectance Spectroscopy. This method uses an infrared beam on the prepared forage sample and then uses prediction equations based on the wavelength formed from the beam reflecting off the sample. This method is quicker and somewhat cheaper than using wet chemistry, but it's also somewhat more limited on the parameters that it's able to measure. Firstly, it can only be used on common types of forages where thousands of samples have been used to generate reliable calibration equations. If you have a slightly uncommon sample that you're trying to have analyzed, or if you're not exactly sure what the forage species is that you're trying to have analyzed, you're better off using wet chemistry. Also, NIR will give you information regarding the digestibility of your forage sample, including crude protein, and a few other parameters related to the fiber digestibility. However, if you're looking for specific information on things like mineral content or sugar content of your sample, for example, you're still going to need to have wet chemistry performed to get those answers. Therefore, it's a good idea to sit down with your county agent before you submit the sample to determine exactly what information you want to get from the sample. There are so many types of analysis that can be done, so it's important to choose the one that best fits what you want to gain. This is an example of a typical forage report that might be generated from the lab. If we look at the top, it tells you what type of forage is being analyzed and the species of animal that it's being analyzed for. It's important to make sure that these pieces of information are correct, since they influence the way the results are presented. If we look just to the right, you'll see an Rfq value or an Rfv value. These stand for relative feeding quotient or relative feeding value, which are calculated slightly differently, but are both meant to give you an estimate of the quality of the forage. If we come further down, you'll see that all other values are given on both as sampled and dry matter basis. This is an important difference to understand. As sampled means that the values given represent the forage as it would actually be eaten by the animal. Dry matter is the value of the given parameters after you burn off all the water. While you might be drawn to using the as sampled values, since this is what your animal actually eats, you need to be aware of this type of thinking. In actuality, if you're trying to determine the quality of your forage, or compare the forage quality of one type of forage to another, it's much more effective to use the dry matter values. This is because when you use the dry matter values, you're able to compare apples to apples. Let's say, for example, you were interested in examining the quality of Bermuda grass growing in your pasture. If you send in a pasture grass sample, your as-sampled values would be extremely low as compared to other Bermuda grass hays, even poor quality Bermuda grass hays. This is because the water content is extremely high in pasture samples. Pastures may be as high as 70 to 80% water, and this makes the density of the other components very low by comparison to hay, which is only about 10% water. This doesn't mean that your horse won't get enough nutrients by eating fresh forage like pasture, though. If you remember our first video on the horse's digestive tract, we said that the horse eats roughly 2% of its body weight on a dry matter basis. This means that the horse will naturally eat more pounds of pasture grass, which might be 70 to 80% water, to meet its nutrient requirements, than it would of hay, which is only about 10% water. A similar analogy would be if you were eating carrots or chocolate. The carrots have a lot more water in them than the chocolate does, so you'd have to eat a lot more carrots to get the same amount of dry matter or nutrients as compared to the chocolate. You would naturally be able to eat more carrots before you got full because so much of what you're eating is water. So when we look at a forage report, if you're actually trying to use it to balance your horse's ration and figure out exactly how much feed to feed him to meet his nutrient requirements, the as-fed column is the way to go. But if you're trying to assess the quality of your forage by using the numbers to compare it to what's normal for that type of forage or to other forages, the dry matter column is the way to go, because you can take samples of varying moisture contents and compare them to each other. If we move down our forage report, you'll see that crude protein is given for the sample as well. This gives you a rough estimate on the protein in the sample, but it doesn't really tell you how digestible that protein is. It's calculated simply by analyzing the sample for nitrogen and then multiplying this number by 6.25%. It's important to remember that something like shoe leather would have a high crude protein content but wouldn't do much to provide for the nutrient needs of the horse. So even more important than the level of crude protein, you need to know the digestibility of the protein. This information is not given on the forage report, but you can look at the digestibility of the fiber to get a better idea of the protein digestibility. In general, as digestibility of the fiber decreases, so does the digestibility and quality of all other nutrients in the forage. So how would you determine digestibility of a forage sample? The most important components to look at are measures of the fiber digestibility of the sample, as well as the digestible energy of the sample. Crude fiber is an older analysis tool that basically just gives you an indicator of whether your sample is considered a forage or a concentrate. For forages or forage replacers, the crude fiber is in the range of about 20%. But if we look at a more energy-dense thing like grain, what we would typically call the concentrate in the horse's diet, they have a much lower crude fiber percent of usually less than 10%. This is again similar to our carrot and chocolate analogy. Carrots would have a high crude fiber content, while chocolate would be more of the concentrate and would have a low crude fiber content. In general, as crude fiber content goes up, digestible energy goes down. We already know this intuitively because we recognize that carrots have many fewer calories than chocolate. This is because the fiber content is high in carrots and low in chocolate. So if we look at a forage report for our horse, our measure of calories for horses is the digestible energy measurement. It's typically reported in kilocalories per pound. And for reference, an approximate calorie requirement for an average light working horse is about 20 megacalories per day. There are about 1,000 kilocalories in 1 megacalorie, so the requirement for that average light working horse would be about 20,000 kilocalories per day. If we look at this sample, the forage provides about 1,200 kilocalories per pound of dry matter. So a horse would need to eat about 17 pounds of dry matter of this forage to meet his requirements. If our horse is about 1,000 pounds, this is just a little less than 2% of his body weight. So it's very possible for our light working horse to eat this forage alone with no added grain and completely meet his energy requirements. And this is an example of how a forage report can help you figure that out. When we're evaluating the quality of the forage, the amount of digestible energy that's provided is reflective of the forage quality. Higher quality forages in general have higher digestible energies. The reason for this is that higher quality forages have fiber that's more digestible to the horse. If we remember back to our earlier video on hay quality, when grass is cut when it's younger, it's more digestible to the horse. The older and more mature it gets, the tougher it gets, and the more indigestible that fiber is. The digestibility of the fiber is measured analytically by the acid detergent fiber, also called the ADF, and the neutral detergent fiber, and that's what we call the NDF. And these values are given on the forage report. In general, the lower these values are, the higher the quality of the forage. We need to remember that not every horse needs the highest quality hay. Our high quality forages have very digestible fiber and a higher calorie content. Some of our overweight horses might not need to eat this type of hay. They might be better off eating a more fibrous hay with a lower digestible energy. This would be represented by higher ADF and NDF values. However, we need to keep in mind that there are upper limits on how high the ADF and NDF values can get before it's considered too poor quality to feed to horses. Hay that has an ADF value of greater than 45% or an NDF value of greater than 65% should be avoided because this can cause colic and other GI problems in the horse. Along the same line of thinking, the Rfq value can be used to classify hay based on quality, from supreme hays, which have a very high Rfq, down to utility, which have a very low Rfq. This table gives you an idea of how different forage species rank as far as their Rfq rating. As you can see, the average Rfq for alfalfa is the highest compared to other forage species, and you can see the averages compared to alfalfa as you move down the table. This table just gives you a visual to show how you might select hays based on the type of animal that you're feeding. At the bottom, you see utility hay really wouldn't be desirable for any of our horses. Standard hay has an Rfq average of about 100 and can be used for horses that are mature and in light work. If we move up to this green box of choice hay, our Rfq gets much higher at an average of about 150, and this should be reserved for some of our harder working horses or growing horses, lactating mares, those types of horses that have very high energy requirements. Another important component to look at is the moisture content of the forage. In our fresh pasture samples, this number might be very high and isn't that important, but it's critically important when looking at hay samples. A general rule of thumb is that the moisture content of hay samples should not be less than about 10% and should not be more than about 20%. This is a pretty tight range, and it's dependent on the hay producer drying the hay to the appropriate moisture content before baling it. If the hay has a moisture content of less than 10%, then it's too dry, and you'll often lose a lot of nutrients to leaf shatter when it's baled. Remember, the majority of the nutrients are found in the leaves. If the moisture content is too high, which would be more than about 20% moisture, then the hay won't store well, and it will likely either mold or, even more frightening, it might be prone to spontaneous combustion, which can lead to barn fires. For these reasons, if you're having the hay analyzed, you really want to pay close attention to this moisture content on your forage analyses. There are a few other parameters that are on this report that we oftentimes don't pay a lot of attention to when evaluating it for quality for horses. However, they could be useful depending on what information you need. If you have the mineral profile of your forage sampled, it will show up in a column here. This would mostly be done if a toxicity was suspected, or if you were relying solely on the forage to provide the mineral needs of the horse and trying to analyze for any deficiencies. Most horse owners provide some type of mineral supplementation, even to pasture horses, so this is not as commonly analyzed in forage samples for horses. Finally, forage samples are always evaluated for nitrate concentration, which is reported at the bottom. Samples that have more than about 4,500 parts per million nitrates are typically flagged by the lab and will be brought to your attention. In general, nitrates are much more of a problem for ruminant animals like cows and sheep than horses. It's recommended that hay that's between 45 parts per million and 10,000 parts per million be diluted with another forage when fed to horses, and anything over 10,000 parts per million not be fed. But the reality is that horses are not very sensitive to nitrate toxicity, and therefore this is not a tremendous concern to horse owners. Finally, there are other types of analysis that can be performed on hay samples, one of the main ones being a carbohydrate analysis. We'll discuss this in more depth when we talk about carbohydrate levels in forages. However, this type of analysis could be added on to any type of forage analysis that you have run if you're trying to monitor the sugar content in your horse's diet. Hopefully this video gave you some tips on how a forage report might be useful in managing your horse's diet. This is an area where your county extension agent can help you tremendously. While there are nominal fees associated with the cost of running the assay, your county extension office provides a free service in working with you to help you collect your forage sample and determine which test best fits your needs. This can be of great help when buying hay in bulk or when trying to carefully manage the diet of a horse with nutritional problems or unique needs. Your county extension agent can help you talk to specialists like me or can provide these results to your veterinarian to help you further manage your horse's diet. Thank you again for tuning in to this video in our Forage Education video series. And thank you to the Georgia Equine Commodity Commission for their funding of this video to provide education to horse owners around the state in the area of equine forage management.